Hey guys, welcome to Pepcoding. In today's lecture, we are going to solve the problem dynamic queue. Okay, so firstly, I would like to recommend you that please go and watch the video of normal queue. Otherwise, you will not be getting a better insight of this question. Fine. So let's try to read the question. You are required to complete the class. The class should mimic the behavior of queue and implement FIFO semantic. You know already what's FIFO semantic. That is first in and first out. And here we have they have provided us. A list of some capacity. Okay, so and they have provided the initialized the variable size q and also front. So I hope you know about this q size and the front. What is the front? It's pointing at the very first element of the queue. Okay, and so what we have to do in this question, add except new data if there's space available in the underlying or print queue or overflow. Okay, so in dynamic queue, what we have to do, we have to accept as many as element we can. Okay, in normal queue, what was there? We just have to accept some limited elements. If let's say its size was something, let's say 5, so we just can add only 5 elements. But in this question, what we have to do, we have to manipulate the code in that way that we can add the elements as much we can. Okay, so let's see the code. Then I let's try to write the code right now. Okay, so what's here, they have okay, some list is there. Okay, and it is initialized by the name ARR. I will say it as array. Okay, so it's an array, and let's say we have this indexes, and let's say my front is here and my elements are like this. I would just again say you that please go and watch the previous video, normal queue video. Okay, otherwise you won't be getting this question. Fine. So in size, what we have to do, as we all know that we are returning the size of the queue. Okay, so what we will we are just maintaining the size of the queue throughout the code. So what we will be doing here, we will be directly returning the size of the queue. Fine, here I'm returning this. So what we were doing previously, we were just having some condition that if the size is full, then we have to print queue overflow. Okay, but in this, what we have to do, see, if my size of the queue is equal to what, length of my this array. Okay, that is self dot array. Fine, then what I have to do, I have to make, what I'm going to do, I'm going to make a new array of double of the previous array's size. Right now its size is 5, so I'm going to make an array of 10 size. That means double of its size, and I am going to add these elements one by one. Okay, firstly I'm going to add 20, sorry 10, then I am going to add 20, then I am going to add 30, then 40, then 50, because my queue is like this now. 10, 20, 30, 40, 50. Then I am going to do what? I am going to update my array with this new array. Okay, I hope you understood what we did. We just made a new array. See, we are just going to make a new array. Let's say its name is this new array of size what? Of size double of length of the previous array. Fine, this. Okay, now I have made a new array. Okay, now I will be doing what? I will be iterating. Okay, I'll be iterating the every element. How? Going to do this while my array is then size of q. Fine. Yes. Now I'm going to do what? Firstly, I want to find my index. And what's my index? You all know. Front plus I modulo of what? Modulo of length of my array. So this is my index. Now I want to do what? I want to just write I want to just push the elements, or I just want to add the elements into the new array. So how will I be doing this? I will be getting my elements from the old array and it in the new array. So here I have added my elements. Fine, and I just want to do what? So let's see what I'm going to do. Initially my array was this, fine, 10, 20, 30, 40 and 50. My friend was here. My size of queue was what, 5. My length of array is also 5. Now if I want to add something, if let's say someone called add 60, then it will enter in this if position. Okay, now my, as you know, because my this array is full, now I am going to make a new array of double of its size, and then this iteration you all know. Okay, how I am going to do, I'm just going to add what elements, the size of the queues, and how, let's say now size of the queue is 5, so I'm going to iterate till 5. So firstly it added 10 at what, 10 at what, 0th index. My I started from 0, so my front is also changed to 0th index. Okay, 20, 30, 40, 50. Now if you want to add something, go and add. Its size is 5. The size left is 5 right now. Okay, so this is how I'm going to add. So plus you, I hope you get it that I have to, update my front also. So for update of front, what I have to do, self dot front, what it will be, what my self dot front will be equal to 0. Fine. If it's entered in this if, then I have to update my this. Then after this, what I have to do, I have to update my array also. So self dot array will be equal to what, eh, new array. That's it. Now we just have to add my elements. Add where, we have to find somewhere, which is equal to what, self dot front plus my size of the queue is size q. I have to do this modulo with what, length of self dot array. Fine. And I am missing some bracket here. So I think this is it. What I have to do now, self dot array my array will be equal to what, my data. And at last I have to do what, I have to increase my size also. Size of q will be plus equal to 1. Fine. So this is my add function. Let's talk about peak. It's nothing. If my self dot size of q is equal to 0, then I have to do what, I have to print q underflow, right? Q underflow, because there are no elements present now. So in the question it said that if nothing is present, that I have to print q underflow and I have to return what, -1. And if something is present, then return what, very first element, that is self dot array of front. That means self dot front. Fine. So I was here, I have returned self dot front. Plus, as you all know, my this remove and peek are very similar. So what I have to do now, I'm going to store my this at something, and I'm going to do what, I am going to update my front plus self dot front will be equal to self dot front plus 1 and modulo of it with of self dot array. Okay, so I have updated my front also, and I have to do what, I have to decrease the size of q also. Size of q will be minus equal to 1, and I have to return my rem. So this is it. Now let's display our function. I equals to 1. So then when I have to write it till 1, and it is, sorry, it's not 1, it's 0. Less than what, self dot size of q, and I'm going to do what, I'm going to display it now. So my disk will be equal to this front plus, I'm sorry, here is self dot front. Okay, so it will be self dot front, copying it because I want to iterate everywhere, and I am going to print it. Print what, print array self array array of what idx, and I am to end it with some space. Okay, because if you see the output, then there will be some spaces after printing. I hope my code is complete. Let's check it. I always forget to add self dot array, this self dot array of self dot front. Yes, it's fine. Yes, it's correct. I hope. Let's try to run this and see if it's correct or not. Some runtime error, and where line 67 print 12. Okay, if file is not, I'm sorry, here some kind of key. It's accepted. Let's submit this and see if it's working. uh Wrong answer, some runtime error is here. Let's see where it is. It must be in some function or something. Okay, let me pause this, then I want to see the. So hey guys, welcome back. So where we were wrong. We were wrong here. We just wrote here Q underflow. It's not underflow, it's underflow. So that's why some cases were not getting passed. So now let's try to submit this. Let's see if all the test cases are getting passed. Yes, it's passing. So I hope you understood this question, and please go and watch normal Q video if you haven't seen that. Okay, first. And if you like the video, please hit the like button and please share and subscribe our channel. And if you're having any doubt, please watch this video again. Okay guys, so thank you. We'll meet in the next lecture.